So we're going to talk about the anatomy of a quadratic equation. Just like the anatomy of the body is like your head, your feet, your nose, your toes, all that stuff. That's the anatomy of the body. We're going to talk about the anatomy of a quadratic equation. Now, has Nate's group done quadratic formula?
Yeah.
Like that?
The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So my group hasn't worked on that yet. But that is a quadratic formula for specifically finding where a parabola crosses the x-axis. That's all it tells you. Okay? It tells you what x is when the parabola is crossing the x-axis. Right? That is different than this. This is called the quadratic equation. Okay? So that's a totally different thing. Now, what I want to talk about is that with a quadratic equation, you have y is equal to a x squared plus bx plus c. And if you know what those letters do, they're actually real numbers in an equation, right? For an example, you might have y is equal to 2x squared plus 4x minus 5. That's an example of a quadratic equation, where a is a number, b is a number, and c is a number. Very seldom, for some reason, do people teach what all these letters do to an equation. And if you understand that, you're going to be miles ahead of everybody else in high school. Because you're going to understand exactly how these different things affect the graph. Okay? So it's going to be really, really a powerful thing. So the one thing that's interesting or important to understand is every single quadratic equation on the planet has all aspects. It has an a, b, and a c. And it has an x and a y. The x and the y will stay as variables, but all the others will be numbers. But every single quadratic equation has all elements that you see there. Now, they may not look like they have all elements. For example, what if I gave you this? What's missing?
The C.
The C is missing. Does that mean it doesn't have a C?
No.
It does have a C, but what is C?
0.
C is 0. C is 0. It actually is there. It's just that you don't have to write it. You don't have to write it, but it is there. Okay, what if I gave you this? Y is equal to 2x squared minus 16. What am I missing now?
BX. The B. BX.
So I'm missing the bx, right? I'm missing the bx. Now, does that mean it's not there?
No, it means it's 0.
It's really there. So it's really technically y is equal to 2x squared plus 0x minus 16. But that's really important. When these things are 0, they tell you things about the graph. That immediately, if you understand what a, b, and c does to a graph, you will immediately know what to do with it, right? And how to respond to it. So can I erase this stuff?
No. Yeah.
Not yet? Just tell me when I can. I'm going to erase the quadratic formula. So the graphing, we're going to be getting into graphing. First we're going to talk about the anatomy, and then we're going to start using t-charts to do some graphing and just sort of see how it works, okay? But graphing usually takes about 2 or 3, well, probably 3 lectures to really get fairly good at it, fairly competent at it. So this is just the first introductory lesson. And so can I erase it now? Mm-hmm. Okay. All right. There are a lot of markers on this board.
Wait, Gary, are you recording?
What?
Are you recording?
I am recording, yes. Sorry, I'm just getting rid of some of these markers so I have room to put things down. Okay. All right. So, first of all, let's talk about A. A. A, so Rowan, first and foremost, A, so in yellow, are you guys in where you're supposed to be?
Yeah.
Is that where you are? Okay. Okay, so just, I need you guys to be quiet for this, okay? This is a lecture. So A tells you whether it is a whether the parabola is a happy face, smiley parabola, or a very sad, frown-faced parabola. If A is positive, it's thinking positive thoughts. That's so exciting, right? Then he's happy. Then parabola is happy. Parabola is happy, right? So if it's a positive A, if the number A is positive, a positive number, it's always going to be this kind of parabola. So it's going to be like this, okay? But if A is negative, poor A, A is negative, then parabola is what?
Sad face.
Right. Parabola is sad face. Sad face. That doesn't look like an F, but sad face. So it's going to be down like that. So that immediately tells you, right? So if I wrote y is equal to negative x squared plus 2, is that going to be a happy face or a sad face?
Sad face.
It's going to be a sad face. Immediately you know that, right? Immediately. If I said y is equal to 3x squared minus 2, what's that going to be?
Happy face.
A happy face, because 3 is positive. Does it make sense? Right? What is A in this one?
Negative.
Negative what?
1.
Negative 1, right? If there's not a number, there is a number, it's 1, right? So it's a negative 1 is your A in this case. Okay? All right, so that's that. But A tells you something else as well. Tells you two things. Tells you first if it's happy or sad. But it also tells you if it is narrow or if it is really, really fat. Okay? So if A, whoops, A, the other A, small a, if A is greater than 1, okay? So let's think about that for a second. So if this is, if A were 1, it would look about like this, okay? It's just a normal parabola. That's a normal parabola. Y is equal to 1x squared. Okay, it's going to look like that. But as soon as I make A greater than 1, it starts to get narrower. Does that make sense? So Y is, 2x squared, it would look like that. 4x squared would look like that. 10x squared would be really, really narrow. Does that make sense? So as A gradually increases, the narrowness of the parabola increases as well. Okay, so if A is greater than 1, parabola is skinny. Okay, but what if A is less than 1? Now what would an example of less than 1 be?
Negative.
Yeah. No, I'm not really talking. Well, actually, I should say less than 1, but greater than. So yeah, exactly. If it's between, well, it doesn't matter. That's okay. I'll just say if. How do I say this? Well, I'm going to just keep it positive for now. Is that okay? If A is less than 1, between 0 and 1, what do I have? What kind of a number is that going to give me? A fraction, right? Right? Between 0 and 1 is going to be a fraction. So here's my standard guy, the standard parabola, right? Where y is equal to x squared. If I start doing y is equal to 1/2 x squared, where a is 1/2, it starts to get a little wider. If I do y is 1/4 x squared, it's a little wider. Y is 1/8 x squared, a little wider. Y is 1/16 x squared, really wide. Y 1/100 x squared. Did I just say 16 or 1/16?
1/16.
I hope I said that. I don't know what I said. But anyways, I meant 1 over, right? 1/100th A would be really, 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 really wide, right? Does that make sense? You get that? So if A is less than 0, meaning it's a fraction, right? Then parabola is wide. Okay? So, y is equal to 2/3 x squared. What is that going to be?
We're just wondering why if
Yeah.
it's negative.
So if it's negative, the same thing is true. The same thing is true. That's why I just didn't want to get it too confusing. If this would be your typical y is equal to negative 1x squared. Does that make sense? It'll look about like this, right? As soon as I do y is equal to negative 2x squared, it gets narrower, it gets skinny, right? Y is equal to 10x squared, really skinny. Y equals 100x squared, really skinny, right?
Wait, what?
But, I mean negative 100x squared, right? What if y is equal to negative 1/2? It would be more like this. Y is negative 1/4. Y is negative 1/8, 1/16, 1/100th x squared. I mean x squared. Does that make sense? It just gets wider. What? Why?
Yeah.
You'll see as we graph it. You just right now I'm just telling you what they do, okay? And you'll see as we graph it. Okay, so that's A. Everybody understand A? That's all that A tells you. It tells you if it's happy or sad. If it's fat or skinny, right? That's all. B. What B does is it moves the vertex, this little point where it turns around back and forth, it moves this vertex to the left and to the right, all right? So B moves vertex left and right. Left and right. Left and right. And I'm going to say, actually I'm going to add to this. And it moves it left and right off of the y-axis. Off of the y-axis. So I'm going to add one more thing to this. If B is 0, if B is 0, meaning it looks like it's not there, right? Like if I wrote y is equal to x squared plus 4, there's no b, right? There's no bx. You guys see that in that equation? If b is 0, that's an example of where b is 0. If b is 0, then the vertex is on the, Rowan, you should be writing all this down in your notes.
I am.
No, you're not. You got all this?
Yeah, most of it.
Okay, I just want to be sure. If b is 0, then vertex is on the y-axis. Okay, that's really important to understand. If b is 0, it moves the vertex left or right. I mean, if b is, what b does is it moves it left or right. But if b is 0, your vertex is on that y-axis. Does that make sense? So, is this vertex on the y-axis?
Yeah.
Yes. Is this vertex on the y-axis? Negative x squared minus 16.
Yeah.
Yes, because b is 0, right? So I know down at 16 is my vertex, negative 16, right? Right here I know up at 4 is my vertex, right? And is it going to be, for this one, is it going to be happy face or sad face? Happy face at 4. So at 4 it's going to be a happy face, like that. At negative 16 it's going to be a sad face, right? So immediately you have a picture of what it's going to look like, right? Just by understanding this anatomy. It's really awesome. Now the last thing is C. If B moves the vertex left and right, what do you think C does? It moves it up and down. Exactly, right. So C, I hope this is still on the thing. I wrote a little crooked, didn't I? Okay, C moves vertex up and down. And there's one other thing that C tells you. What do you think C tells you? What do you guys? What? What is? Think about a straight line equation and y equals mx plus b.
How long it is? Like how tall?
Well, that's a good question. Every single vertex is infinitely tall or infinitely. See what I'm saying? Because when they're narrow, they're still going up forever. But when they're fat, when they're really fat, they're taking a while to get going up forever, but they're going up forever. Does that make sense? They're both going up infinitely high or infinitely low, right? Whether it's fat or skinny. But what about C? What if x were 0? What if x was 0? What does that tell you? You guys remember this? How do you find an X-intercept and a Y-intercept? Okay, remember when we did this? 2x plus 3y is equal to 12. What is that? What form is that in?
It's standard.
Standard form, because x and y are standing on the same side of the equal sign, right? Standard form. Okay, and how do you solve them? You do a t-chart, right? You do a t-chart. And you have x, when x is 0, what is y? And when y is 0, what is x, right?
Yes.
Is that what you guys do? What is that? What are those called?
The y and x.
What you're finding is you're finding the x-intercept and the y-intercept. Do you guys know this?
Yeah.
Right? In order to find where a line crosses the y-axis, what does x have to be? 0, right? In order for it to cross the x-axis, what does y have to be?
0.
0, has to be. So that's what you're finding. You're finding this is the y-intercept when you find out what this is. So, right, I'm going to make this 0, and that's 4. So your y-intercept is 4, and your x-intercept is 6, right? This is your y-intercept, and this is your x-intercept. So, if to find the y-intercept, you make x equal to 0, what is the y-intercept of this? Of this? What would the y-intercept of this be if you made x 0? C, exactly. So C is always a point on your y-axis, always, right? So immediately when you see a quadratic equation, I know that C is a point on the y-axis, always. I've got a point right now, right? Negative 16 is right there. 4 is right there, right? Immediately, if I give you y is equal to 2x squared plus 4x minus 10, what do I know the point is right now?
Negative 10.
Negative 10. Down negative 10, put a dot on the y-axis. Make sense?
Wait, what does the 4x do again?
What does the what?
The 4, you know how it's 2x squared plus 4x?
4x is your b, and b moves it left and right.
Okay.
But it doesn't move it the way you think, right? There's actually a formula. So I'm not gonna teach that formula right now. But there's a way to know where it moves. It does. You think it moves it over 4, but it doesn't. There's a formula you have to follow. So C is also C is the y-intercept. Okay? Make sense? Everybody together on this? So if you understand that, you know so much more than most people do about quadratic equations. Can I erase this?
Yeah.
All right. Now let's start graphing. Is it hot in here or is it just me?
No, it's pretty hot in here.
What? Is it hot?
Wait, really?
Is it
Yeah,
hot?
it's pretty hot in here.
You're making it hot.
I am boiling. I'm gonna just turn this thing.
Ow.
It is 10 after 9.
What are you doing?
Okay, anatomy of a quadratic equation. So we're gonna use a t-chart to do these, right? To graph these.
Okay.
First of all. And let me just be sure I don't do one. I'll do one this one. All right. Is that a quadratic equation?
No, yes, yes. Just the rest of the things are 0.
Right, exactly. Ax squared plus 0x plus 0, right? That is a quadratic equation as long as it says x squared. If it doesn't say x squared, it's not a quadratic equation, right? So we're going to use a t-chart. Does everybody know how to use a t-chart?
Yeah?
Yeah.
In my class too?
Yeah.
Everybody? We did it. We did it.
for like 3 months last year.
Yeah. Right.
Yeah, very graphic.
So things that are important to understand with T-charts is that X is the independent variable. X is the independent variable. And Y is the dependent variable. Right? And what that means is Y is dependent on whatever you choose for X. Right? So X is the thing that you're always going to set figures for and values for. Does that make sense? You're always going to choose your X's. Okay? Now, where is the vertex?
It's happy face.
So, Isla, you guys, listen up. Where is it? So, Jack.
It's at the point of the parabola.
Correct. And where is the vertex for this particular equation? Think about what you know.
At 0, 0.
If B is what moves it off the y-axis. Is B 0?
Yeah.
So we know that the vertex is on the y-axis here, don't we?
Yeah, and so it's easy.
And we know it's at 0, right? I know the vertex is right there. I know that. Does that make sense? Do you see why? Okay. So I am going to choose, since I know my vertex is at 0, I'm going to put my 0 in the middle here. Okay? And I'm going to put a -1 and a -2 here. And I'm going to put a 1 and a 2 here. So Caleb, you're missing important stuff right now, just so you know. If I know the vertex is at 0, right, meaning it's on the y-axis, I'm going to put that number right here. And I'm going to put -1 and -2 above it, and +1 and +2 below it. I have to have 5 points, ideally, to graph a parabola fairly well. With a straight line, how many points do I need? Just 2, really, right? Usually we do 3 in a T-chart, just in case we make a mistake, we can see the mistake. When we try to graph it, if it's not a straight line, we know we made a mistake somewhere. So let's do it right now. If X is -2, -2 squared is what? +4, right? -2 times -2 is +4. It's 4. If X is -1, X squared is 1. So Y is 1. When X is 0,
0.
Y is 0. When X is 1, Y is 1. When X is 2, Y is 4. Now look at this. Here's my 0. This is my vertex, right? 0, 0 is my vertex. And above it, I've got negative X values. And look what I have on the right. I have +4, +1. Down here, I have positive X values, and I have +4 and +1. Do you see that? They're identical. They're identical. They're identical. And it's because of the X squared that the parabola turns around, right? That's why the Y is always positive, because of the X squared. Does that make sense? You see that? So let's try. Okay, so we've got this. So now, these are actual coordinate points. This is -2, 4. And this is -1, 1. This is 0, 0. Right? So forth. I don't bother writing these because they're already in proper order right here. I'll just do this. So I'm just going to graph it. -2, 4. -2 up 4 around there. And then -1, 1. 0, 0, 1, 1, 2, 4. All right.
That's a skinny move.
So that's the standard. So that's a little narrower than I was showing, but that's your standard. Although it's partly because of the way I drew it. If I was using a real graph paper, it would have looked a little wider, right? I could use that, but I can't very easily with this camera on. So that was that. Let's look at it for a second. I know the vertex is at 0. I mean, I know the B is 0, so I know the vertex is on the y-axis. And I know it's on the y-axis at 0, at C. that make sense? So immediately I plot that, and then I just graph these. Okay, let's try this one. Y is equal to, let me be sure I don't use one on here. All right, I think we're okay. All right, y is equal to x squared minus 6. What is b? What is b?
0.
b is 0. What does that tell me?
That's the y-axis.
The vertex is where?
It's 0 on the x.
It is on the y-axis. The vertex is on the y-axis when b is 0. Where on the y-axis is it?
It's
At c. That's my c, right? Negative 6. Right? Negative 6. 1, 2, 3, 4, 5, 6. Dot. I know right away that my graph will be there. Okay. Notice it's at 0 though, right? The x is 0, right? So I'm going to make my t-chart 0 again. It's negative 1, negative 2, 1, and 2. Okay? Since I know my vertex is where x is 0, right? That's where I know it's going to, I've got to have that be my center point. X is 0, and I have to have 2 points below it, 2 points above it, right? All right, so when x is negative 2, y is positive 4, right? Minus 6. Positive 4 minus 6?
Yeah.
Negative 2. All right, when x is negative 1,
It's negative 2.
7.
7. Wait, what? 7?
negative 1 times negative 1 is?
1.
1. 1 minus 6 is?
Negative 5.
Negative 5. When x is 0,
It's 0. 0 minus 6, negative 6.
negative 6. When x is 1,
1 times 1, which is 1. Or negative
1 minus 6 is minus 5. When x is 2, 2 squared is
It's
4.
4
4
minus
minus 6
negative
is
2.
minus 2. Notice the y's repeated themselves, right?
Yeah.
Okay, now let's graph it. So we got negative 2.
Okay,
negative 2.
I understand this really well.
All right. Negative 1, negative 5. 0, negative 6, 1, negative 5, and 2, negative 2. Okay? Fist to 5. You guys get this? Make sense? Fist to 5? Fist to 5? All right. Now, what if I make it harder?
No, Gary, can you not make it harder?
Y is equal to y is equal to negative 2x squared plus 3. Negative 2x squared plus 3. So, okay. Okay. So immediately, what is b?
B.
0.
So what does that tell me?
That the vertex would be on
Then the vortex is on the y-axis.
Vertex is on the y-axis. All right. And where is it going to be on the y-axis?
0.
At C, at 3. So I know it's going to be right there. What does A tell me?
If it's positive, then the parabola is happy, but it's not, so that means it's going to go down.
It's a negative A, right? So it's sad. So it's not going to be happy like these two. It's going to be going sad, right? 2 tells me that it's going to be a little skinnier, right? Right? So immediately I'm going to do my XY. And I'm going to have 0 here. And I'm going to have negative 1, negative 2, 1, and 2. So if x is negative 1, negative 1 squared is positive 1 times negative 2 is negative 2 plus 3. 3 minus 2 is 1. Right? You guys know this? You know how to do this, right?
Yeah, of course, dude.
Wait,
All right.
Gary, so
Oh wait, did I do that wrong? That was this one, right? Did I just do negative 1?
Yeah.
So 1, negative 2, yes. Okay, when x is negative 2, what is it?
4, then 4 times 4 is 16.
Negative 8 plus 3 is negative 5. Am I right? Okay, yes.
Well, I find it easier is if you just forget that the C is there, and you just move the whole parabola. You find all the numbers without the negative 3, and then you just move it up, and then
You can
put
do
your
that.
dot there.
You
and
can
then
do that.
subtract it, 'cause
You can do that. The
numbers
only
aren't so
trouble is
exact.
the -2. And so
So you
that's the
just
next
subtract
lecture.
it, you don't.
That would be maybe the next lecture to explain it. Okay? But yeah, that's a great thing. 0, when x is 0, what's y? 3. When x is 1, it's going to be 1, and when x is 2, it's going to be -5. So immediately, I draw this, -2 from through, let's see, wait a minute, what am I doing? -2, -5. 1, 2, 3, 4, 5. So much easier if you have. And then -1, -1. And then here and here. Okay, so here's my graph. Whoops, sorry. I did the wrong thing. Okay, so you can see the graph is a little skinnier, right? So Roman, you can't talk during my lecture. Yes, you would. So does that make sense? It's a little skinnier. Last thing. What if I give you something that has a b in it? Y is equal to 2x squared plus 2x minus 1. Same thing. You just have to take into consideration that, right? Now the trouble is you don't know where the vertex is because I haven't taught that yet, right? That's a whole nother lecture. But so on the homework tonight, there's one where I'll just tell you on number 10, negative b over 2a. So 4 over 2, so 2. Okay. So anyways, with this one, you're just going to use the t-chart the same way. The trouble is, if you don't know, this is the problem. If you don't know where to start the t-chart, you could be doing, right, if that's your parabola, and this was your x and y axis, and you did -2, -1, 0, 1, and 2, you don't even know where it turns around yet, right? You haven't gotten a picture of it. So on the homework tonight, on the one problem, I'm just going to tell you, I forgot to write it in, but your x and y, this is for problem number 10, it's going to be 2. You want 2 here, so then it'll be 1, 0, 3, 4. Okay? So that'll be for number 10. So that's basically it. I'm going to give you guys the homework to actually practice this stuff, okay?